Hey physicists, what's the crack? So today what we're doing is we're going to see how can we find out the speed of this bullet initially, because what happens is it gets fired into a wooden block, and in that center of mass of the wooden block we know what height it rises by. So can we use that information to find out what the speed of that bullet was initially? Okay, so things I know is that momentum before has to equal the momentum after. So I'm just going to write that first. So I know P stands for momentum. So the momentum before always has to equal the momentum after. Okay. So if I look at the before situation, I have a bullet that's moving and I have a block that is stationary. Okay. It told me the mass of the bullet was 8.8 grams because in physics that has to be in kilograms. So I know the mass of the bullet there is 8.8 over 1,000. I know the mass of the wooden block is 450 grams, but again it has to be in kilograms. So the mass of that wooden block is 450 over 1,000. Okay. So the before situation, my momentum is my mass times velocity. So the before situation is that I have the mass of the bullet times its velocity plus the mass of the block times its velocity, which is 0, equals the momentum after. So after, I know the bullet is embedded. So it says that the bullet gets embedded in it. So I'm just going to sketch my little bullet inside it so I know that it's there. So after, that's the only thing moving. So the mass now is going to be the total mass of the block and the bullet. So the mass now is going to be 8.8 plus 450, and I always do it in my calculator to be safe, is 458.8 over 1,000 times by its speed. Okay, so if I look at my equation for momentum, anything multiplied by 0 is 0. So in order to find out what the speed of that bullet is, because the whole point of the question, I must already know the speed of the block. Okay, so now I have to think, how do I find the speed of the block using the other information? Okay, so I think about energy. I know whatever energy it had before has to go into the energy it had after, law of conservation of energy. Okay, so after, I know that it's got a certain height that it's gained and it's traveling at a certain speed. Okay, and I know that before, we're going to see that all of the gravitational potential energy it gained must have came from the kinetic energy it had. Okay, so again, it's gained in height, so it's gained gravitational potential energy. And the only way that energy came from is because it lost kinetic energy as it's moving. Okay? So what I'm going to write down is that the kinetic energy of the block must have all went into the gravitational potential energy of the block. Okay? So the kinetic energy of the block is 1/2 times the mass of the block, but again, my bullet has been embedded in it. So the mass of my block is the 450. The mass of the block is the 458.8 over 1,000 times by v squared equals the gain in gravitational potential energy, which is our mass of our block, 458.8 over 1,000 times by g, which is 9.81 on Earth, times by the gain in height, which is 0.63. So I can see now I have enough information that I can find out what that speed of that block was. And that's exactly what I needed. I needed to know what the speed of that block was. So all I go down is actually, if you look at it, I can cancel mass both sides. So you need to do that math. And to find the speed of the block, or v squared, all I do is 9.81 times by the height, 0.63. And then I'm going to multiply both sides by 2, multiplied by 2. So when you put it in your calculator, 9.81 times 0.63 times by 2 gives me a v squared of 12.36. But I remember that's a v squared, so in order to find v, I take the square root of the answer. So I take the square root of my answer to get a final answer of 3.52. So 3.52 meters per second. So that's the speed of my block. So now I can pop this number into this equation. So again, what we had before has to equal what we have after. Okay, and I just said anything multiplied by 0 is 0. So we're going to simplify this. So I have 8.8 divided by 1,000, which is 8.8 times 10 to negative 3. I did not need a calculator for that. But anyway, 8.8 times 10 to negative 3 times by v must equal this number over 1,000, which is going to be 458.8 times 10 to negative 3 times its speed, which we know is 3.52. So 3.52. So to find v then, I can do this math and divide both sides by 8.8 times 10 to negative 3. So what I have is 458.8 times 10 to negative 3 multiplied by 3.52, and then all divided by 8.8 times 10 to negative 3. So when I do that math, 458.8 times 10 to negative 3 multiplied by 3.52, and then that final answer divided by 8.8 times 10 to negative 3, I get a final speed of 183.52 meters per second.